My name is Figo. I'm from Hunan University. Today, the title of my presentation is Faster Pixel Matching Algorithm for Automated Self-Build Welding based on the integration of 2D joints and structured light cameras. The first part is the background of my research. The self-build are widely used in many fields, like steel, bridge, composite structure, and so on. In civil engineering, the self-build are usually used to connect concrete component and steel component to increase the stiffness and the bending resistance. And this picture shows the process of self-build welding. We assemble the ceramical ferrule and the self-build. There will be welding arc when you elevate the stud, and then complete the welding. This process is simple. There are many automation methods to complete it. Therefore, how to find the position of a welding point on the surface of components quickly should be paid more attention. There are many tools to connect concrete components in a bridge. The workers must spend much time to mark line on the surface of a component, about 10 seconds per tooth. In civil engineering, the commonly used self-build diameters are typically above 12 millimeter. Consisting over 50 of the self-build composition yields the level of automation remains extremely low. Additionally, workers are facing the risk of electric shock and a very long period of high intensity labor. For self-build welding, the workers always keep awkward postures, and there are many substitutes to be welded. There are many automated methods to substitute repeated work. However, existing methods have different drawbacks. The first method needs a 3D model to guide the robotic in the welding process. It requires that we construct a 3D model based on 2D joints. This process is time-consuming and it does not align with the 2D design convention in civil engineering. Therefore, someone provides a method based on 2D joints. This method supplementing missing information in the direction of Z axis using a light section sensor. This method requires controlling the movement of the light section sensor in a specific direction to origin point flow data. In contrast, the structured light camera can capture point cloud data within a large area with a simple overhead shoot. Above all, we provide a method based on 2D CAD joints and the structured light camera to find the pixel coordinate of welding point. The second part is our research method. In the RGB image, we mark the welding point. Why we need to find the pixel coordinate corresponding with the 2D welding coordinate. In this figure, we have two welding points, P1 and P2, with the same x and y coordinate, but there are different values in the direction of z. According to the pinhole camera models, there are two pixel coordinates because different value in the direction of the z-axis. Above all, the pixel coordinates can't be solved due to the missing depth and value and the coordinate. When the 2D welding coordinate occurs in the field of a camera, we can search each pixel coordinate and calculate the XYZ coordinates in the word frame. When the distance between currently searched pixel and the 2D welding coordinate reduced to an extremely small values, this pixel coordinate can be considered the pixel coordinate corresponding to 2D welding coordinate. Apparently, the efficiency of brute force search is extremely low. Therefore, we introduce a new algorithm, faster pixel matching algorithm, to address this problem. In the figure of right part, we can divide the image into 4 parts. In the first step, we should search the center pixel coordinates of an image and determine the 2D coordinates in which part. Therefore, we can determine the search pixel coordinates in the second step. Look at this. And the center point of third part is the search the pixel coordinate in the second part. Second step for an image with a resolution 1,200 multiple by 1,000. We just need 11 iterations to find a pixel corresponding to 2D welding coordinates theoretically. The second part is about experiment. In our experiment, we developed an auto CAD plugin to extract the coordinates of stud in local frame, and this video shows the process of extracting the 2D coordinates. We can quickly extract the information that we need. For a complex joint, it also has a good performance. In our experiment, we adopt structure light camera to map 2D welding coordinates into the surface of a 3D component. And the green point are the pixel coordinates of 2D welding coordinates. The average positioning occurrence is 4 millimeter. The positional deviation in the direction of XY plane should not exceed 3 millimeter, but it is feasible to reduce the error to below 3 millimeter through precise positional calibration between the marking board with the 3D printed component. As a result, we expect the iteration process of BFS exhibits linear decline. In theoretically, FPM only need log to the base 4 of resolution iterations to find the pixel coordinates. We just need 11 times to find the pixel coordinates. But in fact, the efficiency of FPM process is affected by the iterations of local search. Based on our experiment, the local search process can be significantly shortened or even avoided when the quality of the depth map is improved by using a better camera with a high accuracy in calculating the depth state. We adopt the depth in equivalent value for the currently searched pixel with the missing depth is determined by calculating the average depth of a non-zero point within a 7 multiple by 7 pixel range centered on it. Therefore, it becomes challenging to converge to values below 1 millimeter, especially in case of poor depth map quality. Hence, local search process is necessary for further refinement under such circumstances. The fourth part is about the vision of my research. Above all, we provide a method FPM. It is based on 2D CAD joints and the structure light camera. FPM can achieve the requirement of code with a positioning efficiency up to 105 times faster than work. In the future, we will continue to improve the efficiency and the accuracy of FPM with the potential for application in actual production line. Thanks for your listening. If you want to chat with me, you can contact us.